Hey everyone, today we're going to look at P2 paper for January 2023, International Level Edexcel. We're going to browse through the work solution and I'm just going to talk over the top of it. Okay, so let's get started. First question, we have a function y equals f of x. Now this is a common kind of question which deals with transformations because it does not give you the equation, so there's no other way to approach it except from your knowledge of how functions work. First step is trapezium rule. We are given all of the values, so there's nothing to calculate. This is a standard question for, let's say, someone who's doing sciences, where you could do an experiment and get specific values and use those values to determine other factors. We want to integrate between -1 and 1. So we set up our equation. Our distance between our x values, as you can see, goes up by 0.5. That's our h. So state that h is 0.5. And by the trapezium rule, you take h, divide by 2. You take the first value, the last value, and double the remaining values. So the first value of 2.287, the final value of 2.834, and then you double the sum of the middle three values here. And that should give you a quite straightforward 10.52. If you made the error of trying to calculate it any other way, you would not get any marks for this question. It specifically asks for the trapezium rule. Next up, comprehension of transformations. Use your answer to part A. This must be using your answer to part A. Estimate our first value is f of x minus 2. Now, as you know, when you integrate a multi-term function, you can separate it into the integral of each individual function. And that's all we do here. So we take our function f of x minus 2, and we separate it into the integral between -1 and 1 of f of x, subtract, because it's a subtract, the integral of -1 to 1 of 2. So this first part of the function we already know is 10.52. So we need to evaluate this second part. So integrating 2 gives 2x. You put -1 and 1 in there, so 2 times 1 is 2. 2 times -1 is -2, but you're subtracting, so it's 2 minus -2, which is 4. So all you do is you take your answer to this first integral and subtract 4. So 10.52 minus 4 is 6.52. Now the second part, this one's interesting. Now here, this is a horizontal translation. You should have studied this in your GCSE as well as P1. It's a horizontal translation of 2, and because it's a negative here, that means it moves the whole thing 2 to the right. But if you look at these limits, we're going from -1 to 1, and we're going from 1 to 3. These have also moved 2 to the right. So if you look at our graph and we imagine moving our graph 2 squares to the right, so -1, -2, so we would end up with something that looks a little bit like that. But our limits would also move 2 to the right. Then our green area here, which is what we found out in the first question, and our purple area, which is what they're asking in this question, as you can see, are identical. Since we've moved the whole graph 2 to the right and the limits 2 to the right, these two areas are both the same. So the answer to part 2 is simply 10.52. Moving on to question 2. So a little bit of comprehension, understanding the question, seeing our approach before we start is critical for this kind of question. We have a cuboid. We know it's a cuboid because we're told it's a cuboid. We have a variable x, we have a variable length here, 3x, and we have a height h. So we've got 2 different letters. We know the volume is 972 centimeters cubed. We also are asked to find the surface area. And if you look at that formula for the surface area, you will see there is no H in it. So we need to create two formulas, one for the volume, one for the surface area. And we need to solve them using a substitution to get rid of H. And that would give us our surface area. So the volume is going to be x times 3x times h. So that's 3x squared h is 972. So therefore h is 972 divided by 3x squared, which simplifies to 324 over x squared. But what's the surface area? So this front side would be x times h. This side would be 3x times h. And this top would be 3x squared. But what we're doing is we are taking these three expressions and we're doubling them because each side has an opposite. So 3xh plus xh is 4xh, 4xh plus 3x squared, double it, and you get 8xh plus 6x squared. But we know h is 324 over x squared. Substitute that in and simplify, and you should get exactly the answer requested. Even if you can't do that, you can still do part B. Differentiate 6x squared, that's power times coefficient, would be 12x. And differentiate 2592x to the minus 1 will be 2592x to the minus 2 with a negative in front. Our gradient is equal to 0 at turning point when we're looking for a stationary point. So you make it equal to 0, move the 12x on the other side, or the 2592 over x squared on the other side, multiply by x squared, divide by 12, and then finally cube root will give you the x value of 6. So that means at 6, we have a stationary point. But what is that stationary point? Is it a maxima or a minima? In order to do that, we need to do the second differential. So you go through the steps of differentiating again. 12x becomes 12. And we put x equals 6 in it. Now, we don't actually need to work this out. All we need to know is this at x equals 6 going to be positive or negative? Well, 12 will always be positive. And 5184 will always be positive when x is positive. So substituting x in, you can work out the value of 36. But just by observation, you can say, well, this is positive and this is positive, so their sum will always be positive as long as x is 6. So therefore, our second differential is positive. That means our gradient is getting bigger. So our graph looks like that. So it's a minima. To find the surface area at that point, well, we have a formula for the surface area, right? It's 6x squared plus 2592 over x. We know that x is 6. Substitute it in, and you get 648. Easy peasy. Find the first 4 terms of the expansion. So this was pretty well answered. So remember this 70 on your calculators, you can write as 7C0 and 7C1, 7C2, 7C3. So you should simply do 7C0 times 2 to the 7. Let the calculator do the work. 7C1 times 2 to the 6, and then divide by 8. 7C2 times 2 to the 5, and then divide by 8 squared. 7C3 times 2 to the 4 and divide by 8 cubed. Find out the exact values, the fractions, coefficients, you write out your answer. These are the first four terms of the expansion. Now part B, we are told that the coefficients of x, x squared, and x cubed are the first three terms of an arithmetic expression. So if you have an arithmetic expression, that the first term is a, the next term is b, another consecutive term is c. If they are an arithmetic expression, then the distance between each term is the same. So if you take any term and subtract the previous one, the answer will always be the same. And this is what you're going to use. So let's say we had 1, 5, and 9. We can see here that 9 minus 5 is 4, but also 5 minus 1 is 4. And we're setting this up using our three terms here. 56k from here, 21k squared over 2, and 35k cubed over 32. Oh, there's a typo there. That should be 32. Okay, so we set it up. We put everything on the same side, multiply everything by 32 if you want, and that will get rid of our fraction. And simplify it, you get a quadratic, and then you solve the quadratic. It does factorize, but you can use your calculators to solve it either. Yeah, it doesn't really matter, both will get the mark. So we've got two values of k, 16 or 16 over 5. So having a look at the question, find the possible values. So we have two possible values of k and both are acceptable. Okay, cool. Number 4, using the law of logarithms solve. So we can write 2 as log 3, or we can put both our logarithms on the same side. Yeah, that works as well. So putting the logarithms on the same side will give you log 3 5x plus 7 minus log 3 4x. If you minus logarithms and the base is the same, you can write it as a division. So 2 is log 3 5x plus 7 over 4x. So therefore, writing it in exponential form, 3 to the power of 2 is our fraction. Multiplied by 4x squared. Subtract the 5x from both sides and divide by 31. Yay, 3 marks. Part 2. Now this one's a little bit tricky. You have to understand what's going on here. In the first expression, we're doing log a of y to the r. In the second expression, all of log a is raised to the power of r. So since all of log a is raised to the power of r, you can't just bring that r down. Yeah? So let's see how we cope with it. So we have two expressions here. We have when r is 1 and when r is 2, and we're going to add them together. So we're going to write these out. So putting r is 1 in there, we get log a y1, and putting 2 in there, you got log a y2, log a y1, and then log a y all squared. So what do we do then? Well, we have a log a y1 on both sides, so we can just subtract that. And you know this power here, because it's only on the y, not on the whole thing, we can write it as a coefficient. So 2 log a y's is the same as log a y squared. You can divide both sides by log a y, and that will simply give you log a y is 2. Writing it in exponential form, a to the power of 2 is y. Find y in terms of a. Y is a squared. I think that was quite a tricky question. So well done if you got it right. Okay, factor, remainder theorem. Fun. Given that x minus 3 is a factor of f of x, show that. Okay, so that means we could put x equals 3 into this formula. And since this is a factor, f of 3 should be equal to 0. So 3 cubed is 27. P plus 3 times 9 will be 9p plus 27. Minus 3 plus q. Multiply out your brackets, simplify your terms, and you get your 9p plus q is negative 51. 2 marks. Given also that when f of x is divided by x plus p, the remainder is 9. So this is really saying that f of minus p is 9. That means if we replace every x by minus p, we should get 9. So multiplying it out and simplifying will give you the 3p squared plus p plus q minus 9 is 0 as required. Now find the value of p and q. Well, even if you can't do part A and B, you should be able to do part C because it's just simultaneous equations. What does q equal to? Well, q is minus 9 minus 51. So instead of q here, write minus 9 minus 51. Simplify those values. Solve the quadratic for p. You get p equals 6. You plug it back in here. 9 times 6 is 54. So minus 51 minus 54 is minus 105. Now, you can use long division or equating coefficients for this next one. I quite like equating coefficients for this. So we know that f of x is this expression here. And it's the same as x minus 3 times something. So x minus 3 times 1. We know that x minus 3 is a factor. But what's the remainder? So we can use long division. Or we can equate a coefficient. So looking at our term, given that we now know p and q, we know what our expression is. And we're going to see, well, if you've got an x here, and you've got an x cubed here, then that tells you that this is going to be x squared. You have a minus 3, and your answer will be minus 105. Minus 3? How many minus 3s do we need to get minus 105? Well, do a little divide, and you will get 35. So remember, we're doing x and minus 3. And we're doing x squared ax and 35. And we're trying to find out what that a value is. Now we know that there are going to be 9 x squareds. So how would you make x squared by combining? Well, you could do this times this, which would give you ax squared. And you could do this times this, which would give you minus 3. So therefore, a minus 3 is the number of x squareds, and 9 is the number of x squareds. So therefore, a minus 3 is 9, and a is 12, giving you all the marks. So for this first video, this is the last question, so we're just doing up to question 6. The circle C has equation x squared plus y squared plus 8x minus 4y is 0. Find the coordinates of the center and the exact radius of C. So we're doing completing the square here. So it's x squared plus 8x will give you x plus 4. 4 squared is 16. We want to subtract the 16. Y squared minus 4y, so half of minus 4y minus 4 is minus 2, so it's y minus 2. And y minus 2 squared is 4, and we don't want that. So moving the 16 and the 4 on the other side gives you 20 on the other side. Remember, that's the radius squared. So you need to square root it, and that'll give you 2 root 5 for the radius. And the opposites, the zeros of these, so what value of x would make this 0? Minus 4. What value of y would make this 0? 2. So the center is minus 4, 2, and the radius is 2 root 5. The point P lies on circle C. Given that the tangent to C at P has this equation, find the coordinates of P. So, okay, so we know what the formula for the circle is. And we also know that rearranging our straight line, x is minus 10 minus 2y. If we substitute this equation into here for x and simplify it, we will get a quadratic in y, which simplifies down and factorizes to give you y is minus 2. Inserting that back into equation 1 here. Oops. Inserting that back into equation 1 here will give you x is minus 6. So again, that gives you the coordinates. Now, for the last part, find the equation of normal to C at P. Give me your answer in the form y equals, so y is the subject. So we know that this equation here, if we make y the subject, it has a gradient of minus a half, and there should be x here. Therefore, the normal is the negative reciprocal. So turn it upside down, it's 2 over 1, make it negative, is plus 2. So we know it's y equals mx plus c, but m is 2, so y equals 2x plus c. But we also know it goes through this point here. So we can insert those coordinates into here. So minus 2 is 2 times minus 6 plus c. So that's minus 12. Minus 12 minus 2 is 10. C is 10. There's your formula. Y equals 2x plus 10. Okay. I'll see you for the second part of the video.